The book I used. So many of you have been asking about how to start out in electronics, and I did put up Platt's book the other day, which is just one volume of, I believe, a 3-volume series, which if I get my hands on the rest of it, I will. He has a very different approach. His approach is to literally take things apart, see how they work, which is not a bad idea. But, you know, take a look if you want. What I wanted to do is introduce to you today the book that I learned, the only book I really had when I was learning electronics. Now, I didn't really learn the bulk of electronics, like the electronics that I really know, and really gained expertise in and experience. This is not really the way I did it, but this is the book that I had when I was growing up. Okay, I will make another video kind of showing the process of how I learned electronics, but it was fairly untraditional in a sense. So, you know, just to be kind of short about it, how I learned is basically reading schematics. By studying schematics and building things is kind of how I learned. So maybe through that kind of process. I didn't have one integral book. The only book that I did have is this book, and this is published by Elsevier, which is kind of unique. That's a pretty prominent academic publisher. So for them to have a book like this seems to be kind of unique, at least to me, which I didn't know when I was, at the time. I would have never been concerned about that. But having a pretty long stint in academic work, I recognize that publisher very well, and yeah, it's kind of unique that they have a starting electronics book here. But let's just go into this really quick. I'm going to tell you right off the front, like, this is pretty basic, and this is why I said I didn't learn that much from this, is that it's a pretty basic book, but it does yield some benefits. I flipped through it the other day. It does yield some benefits, especially for those that are talking to me and asking me questions and are interested in learning. That this might actually be a very good book to start out with for just learning electronics here. So let's zoom in to the table of contents here, and we'll see first chapter, very first steps on the boards. So this book is very much predicated on how to set up a breadboard and use a breadboard and all that. And that's kind of why I didn't really learn a lot of electronics, because I was never a breadboard person. I was a through-hole person. I was getting those wafers or whatnot. It's slipping my mind now what you call them, but like those prototype boards those prototype soldering boards, and doing through-hole parts on them. That's how I did everything. So I soldered everything. Measuring current and voltage, capacitors, IC, oscillators and filters, diodes part 1, diodes part 2, transistors, analog integrated circuits, digital integrated circuits part 2, glossary, quiz questions or quiz answers, and index. So one thing I like about this book is it's brief. There's not that much to it, and it's very simple. So I think in that way, it's very much a good introduction to those that have no prior experience. Okay. So in the introduction, it says, most people look at electronics diagrams or a printed circuit board and have no idea what they are. One component on the board and one little squiggly on the diagram looks much as another. For them, electronics is a black art practiced by weird techies spouting untranslatable jargon and abbreviations which make absolutely no sense whatsoever to the rest of us in the real world. But that needn't be. Electronics is not a black art, it's just a science. And like any other science, chemistry, physics, or whatever, you only need to know the rules to know what's happening. What's more, if you know the rules, you're set to gain an awful lot of enjoyment from it, because unlike many sciences, unlike many sciences, electronics is a practical one, more so than just another science. Scientific rules, which electronics is built on, are few and far between, and many of them don't even have to be considered when we deal with components and circuits. Most of the things you need to know about components and the way that they can be connected together are simply mechanical and don't involve complicated formulae or theories at all. So I think that's a pretty good explanation here. That's something I kind of wanted to touch on in another video. For people that are wanting to learn, I know I shared the Practical Electronics for Inventors book, and I herald that book, and I told you how much I'm in love with that book and how good I think it is. And then the Art of Electronics book, I went through that and showed you, well, yeah, this is very technical, and it gets very deep into it, and I really appreciated that. I like that aspect. But I want to be clear that you don't need to go that deep to just learn electronics and to build some things. So in the coming videos, I'm going to lay out some stuff and get something organized for some projects that a young electronics user, when I say young, I don't mean necessarily in age, but in experience, a young electronics enthusiast or DIYer can start putting some stuff together and really make some sense of some things without getting into a lot of the theories and the formulae and stuff like that. Like it says, especially when you get familiar with things, a lot of things you do by rule of thumb, okay? You're not really always going to grab a calculator or do some kind of formulas and all that kind of thing. So tools of the trade, so he's going through some of the tools. So he got some snaps here, he's got some needle nose pliers, a little soldering iron. He gives an explanation of electricity, very basic. He gives an explanation of charges. Okay, now he's going into batteries, voltage and current. Now he goes into a little bit of Ohm's law. Very basic. It's very basic, but I think it's very good. There's nothing to get confused about in here. He goes into the denominations of amps, milliamps, microamps, picoamps, femtoamps. He does the same with voltage, resistance, now he gets on the boards. There's a little quiz questions here, over here. If you see this, he's got some quiz questions for you. But aside from that, going on to the next chapter on the board. So he's going to start breaking out the breadboard, and this is what happens in every chapter hereafter. He'll have a list of components, and then you'll put in these components in your breadboard. He'll show you what to do and what you're going to set up here. Okay, so now he's just outlining, showing you a little block diagram of a breadboard. He's going to get into some ICs here. I've got some pictures of some breadboards. Again, like I said, I was never a breadboard kind of user. One thing for that, one reason why it's worth explaining why I wasn't. I'll tell you why, because as I said in previous videos, a lot of my electronics experience was with amplifiers, building amplifiers, and that doesn't mean like full-scale amplifiers. Amplifiers are just a circuit, right? So that could be preamplifiers too, right? So amplifiers could just be one transistor amplifier. So in building amplifiers, you don't really want long-running leads because that can pick up a lot of noise. So that's part of the reason why I never really liked to do things on a breadboard, because those long-running leads can lead to a lot of noise, and that won't give you actually a true representation of the integrity of your circuit. Like I talked about in previous videos, electronics isn't just about the circuit. How if the circuit hits your benchmarks, let's say if you want a certain voltage swing or you want a certain frequency curve, that's all well and good, but if the circuit is noisy, most of the times, especially in the audio world, it's not worth anything, right? If it makes too much noise, it's useless. So I didn't want to make these kind of circuits where I would incur noise just by the fact of how I was prototyping them. So I would solder them, and that would give you a truer representation of how they would actually sound. So that's the case for why I didn't use breadboards very much. He's going into ICs, and this is kind of, I think, well worth documenting here. He shows an IC. This is kind of why breadboards are made the way they are. If you see the breadboard, if you look close, you have a picture here too. In the middle of a breadboard, there's always this gap. Well, that gap is really made for ICs to be stuck in the middle, and then you have so many odd legs. You have half the legs on one side, half the legs on the other side. That's really what they're meant for. The first circuit, then he introduces a multimeter, measuring a resistor on the breadboard, okay? Resistor color coding, looks like a voltage divider there. Doing some Ohm's law stuff, it looks like, some putting resistors in series and parallel. Then he has a resistor network here. More complex circuit. Measuring current and voltage. Now this is measuring current. We're 68 pages in, just for reference, to see how quickly it moves. Now it looks like it's introducing potentiometers, page 72. A little quiz at the end again. Here's the quiz questions. Capacitors. So now he's going to show you the components you need for capacitors, and we're going to get into some theory about capacitors. Looks like a pretty good representation. Then symbology for a capacitor, so polarized, nonpolar. Again, I really do like this book. I appreciate it now more than when I was young. When I was young, I felt like, just didn't have enough information. But now, especially in this context, in the context of referring this to people that are wanting to learn, this is probably the most simplistic, the most erudite, the most straightforward book that I think that I've presented so far. So now he's getting into time, like time frequency curves, time voltage curves for capacitors, like the time it takes to charge, time it takes to discharge. Okay. Chapter 5 is going to be ICs, oscillators, and filters. This is where you might find some unique things. This is where he introduces the 555 timer. And that's something I didn't do either when I was in electronics. Again, I was more into audio electronics. Being a musician, I was really into audio electronics, and that was really the only area that I really cared about and wanted to know about. I didn't really do things when it came to like functionality. I did it for sonic quality. And sonic enjoyment, not necessarily for like functions. So I didn't do a lot of strange experiments that people do with like 555 timers and things of that nature, because I didn't have a purpose for them. If I had a purpose, then I would have. This is like so the multi-vibrator, so making a flashing LED thing. Now if I wanted to put a flashing LED on an amplifier, I guess I would have, CC, but usually there's not really a purpose for that. LEDs now he's introducing as well. Now we're getting into some filters, the basic filter, low pass, high pass, diodes, chapter 6. This is page 123. Diodes. A nice representation of the anode, cathode. This is how it looks with the markings on it, how it looks with a ring, how it looks with a slope. The marking is usually the most prevalent. And he shows bias and reverse bias here. As he's looking at the current flow or transients when a diode gets turned on. So right around 0.6 from 0.6 to 0.7 it starts to ramp up. That's when the breakdown voltage occurs. Zener diode he goes into and reverse bias. That's pretty cool that he talks about that. A little more advanced, and then it's done. If diodes 2 or diodes 1, oh, I guess it keeps going on. That's strange. No, I guess that was supposed to be the diodes 2, but I guess we found a typo here. This is chapter 7, supposed to be diodes 2, because as it states there, this is diodes 2. So next chapter of the diodes, it gets into a little math here on load lines. Oh, then gets into a little bit of rectification. There you go, a half wave rectifier, full wave rectifier, full wave bridge rectifier. Very useful, very simple to understand the way he has this. Zener diode to stabilize the output voltage. Very nice. I like that he gets into talking about ripple and things of that nature. Transistors. I always looked at this, this looks like a what is it? What do you want to call this? Like a germanium transistor that he has as an example, it looks like. And he shows you the inside of a transistor. Very good imagery, very good depiction there of what someone would want to have in their head. That's the inside of a transistor, so it's two diodes opposing each other is basically what a transistor is. Okay. He shows you NPN. Current flow through the transistor. A difference between NPN, PNP. Then we have a circuit to test a transistor with variable base current. So my guess is, and this might be cool if you could really use this to test, I don't know how effective it would be to test every transistor you have, or I guess it would just show you if it works or not. But you plug in the transistor here, turn the potentiometer on, and that will see if it will carry current to the LED. Another quiz section. Then we have analog circuits going in chapter 9, and he uses a 741. Okay. Which I believe is a fairly general op-amp circuit. There he shows you an internal diagram of it. Inverter, non-inverting, offset null, positive and negative inputs, output. Okay, so here it is. Oh, so this is only a one channel op amp, and that's the pinout. What's it going to do with this op amp? Let's see. That I don't know. Our first experiential circuit, a non-inverting amplifier with 3 rail power. A 3 rail power supply. I don't know why he calls that 3 rail. My understanding is that would just be a 2 rail. So he has positive, negative. He has a positive, negative going to some 9-volt batteries, and that will give you 9 volts on the positive end, 9 volts on the negative end. Oh, now he takes this circuit from inverting to non-inverting. That's pretty cool that he does that. So it is very, very simple. It doesn't. This book, I like it because it's hard to get confused with this book because it's pretty straightforward. It doesn't throw a lot at you at once like a lot of books. A lot of books would have had the inverting and non-inverting on the same page, and one had 10 other circuits. Kind of just like the inventor's book, the Practical Guide for Inventors. Again, that's not a book to learn though. You know. Then he looks like it says a voltage follower here. Look at this voltage follower. Cool. Offset null. Chapter 10, Digital Integrated Circuits. So he's showing you a little bit of binary that goes into this. All the ones and zeros. Shows you a 2-input OR gate. There's your OR gate there. It's like a truth table that he has there. I mean, you have a 3-point input, 3-input AND gate there. The IC that he's using here is a 4001, I believe. Then he kind of shows you how to make the same thing with a transistor, which is pretty cool. I think that aids into you know, understanding that a lot of things in electronics are interchangeable. Some things are just more convenient than others to use for certain processes. Here we have a circuit to investigate the OR and the NOT gate. The Boolean way, it's logical. So he gets into some Boolean algebra. I'm sure it's not too much. He gets into a little bit of it. Digital Integrated Circuits Part 2. Now he's getting into chips with multiple gates in them. Multiple gates, probably showing the most usual suspects here. Cross-coupled gates. Bistable, NAND. And that's the end of chapter 10, I believe that was. Was it 10 or 11? Chapter 11. So that's the end of that. Then he has a glossary here. He goes through some vocabulary. 180 degrees out of phase, which is more of a phrase than a definition. Active, amperage, amplitude, analog, astable vibrator, avalanche point, avalanche breakdown. That's involving diodes, axle, base current, base collector emitter. So all of this verbiage in here is very good to know about. Bridge rectifier, breakdown voltage, characteristic equation, closed loop gain, conventional current, corner frequency, comb, discrete, farad, feedback. This is very good. Now this is something I didn't see in the rest of the books. This glossary, very, very beneficial. Half-wave full-wave rectifier, very beneficial for someone just starting out to get used to some of these terms in here. Open loop gain, op amp, pointer, potentiometer, radial, self-bias, square wave, voltage follower, voltage divider, wiper, Zener diode, zero adjust knob, zeroing a multimeter, and he has a list here of the components used. So you can get all these components and you can do every one of the projects in here. And then there's just an index here, and then he has the answers to all the questions and the quizzes. So again, all in all, I think this is a great book for someone just starting out, especially if you want to do some of these projects. And I would just, or if you just want to do a couple of them. Again, none of these books necessarily you have to do everything that's in there. Decide what you want, what you're interested in, and once you can break away from it, then break away and go on and learn more and create your own curriculum in a sense. That's very much how I use this. Like I said, I always thought it didn't have enough information, but it didn't have enough information regarding the stuff that I wanted to learn. So, after getting maybe halfway through it, I might have just used it more of a reference, or it became really basic to me. But that's good, because that shows progress. That shows it did help, a good introduction. But then you break away. Like once you break away from doing stuff on breadboards, which I think most will break away from that fairly quickly. Now that doesn't mean that professionals use breadboards all the time. Like, it's just a matter of preference. That's not necessarily that only beginners use breadboards. Everybody uses breadboards if they want. But I'm saying, just starting out, if you're doing breadboard stuff, and then you feel comfortable to come up with your own circuit, and you want to have a concrete circuit and an idea that you want to get printed, or you want to do some point-to-point soldering on, and you actually want to build that thing out as a permanent circuit, you'll get there not too far after being exposed to this, I believe. So definitely, I think a very good introduction. I would definitely look it up, because it's probably not very expensive. Out of every book that I've showed thus far, this is probably going to be the cheapest book. I would assume, at least just by the size of it, and by the what do you want to say, about the lack of popularity, that I don't think it's that popular of a book in this circle. So it probably pretty easy to get your hands on this. And yeah, check it out. Starting Electronics, this is the 3rd edition. Okay, thanks for sticking with me, guys. We'll have more for electronics education pretty soon here. Thanks.